Hello programmers, welcome to the video. So today we will be solving this is today's Leetcode challenge of 8th of October and quickly jump into the question. So I will explain that there is two arrays given, spells and portions, and with the different length n, n can be same respectively, where spells of I represent the strength of ith spell and portions of j represent the strength of jth portion. You are also given an integer success. Okay, so we have given three inputs: spell, portions and success. Okay, you can see from the functions as well. Now a spell and portions pair is considered successful if the product of their strength is at least success. You don't understand what it is mean. Okay, return the integer array pairs. Okay, pairs of length n, where pairs of I is the number of portions that will form a successful pair with the ith spell. Let's better understand this with the example. So for example, for the example number 1, we are given that space is 513 and portions is 1 2 3 4 5. We have a success 7. Okay, so if what we are doing, that's the output 403, some counts. Okay, so let's explain. Zeroth spell is 5. Yes, zeroth spell is 5 here, and if I multiply with this array 1 2 3 4 5, it will become 5 10 15 20 25. 4 pairs are get successful. Why? What is the definition of successful? Successful if the product of their strength is at least success. So at least success means greater than equal to success. We have to find. So there is 4 element which is greater than equal to success. So that's why we need we need to count like this. For first spell, if we multiply, all will be like 1 2 3 4 5. So there is 0 pair which is successful because all of them are less than 7. Then for the 3, we multiply with the array, we will find 9 12 15. So 3 pairs are successful. Okay, because 3 values are greater than 7, and we have answer 403. Got it. So I hope you understood the problem at least. Okay, and with example number 2, let's understand better. 3 1 2. Let's run on example number 2 so you can understand this better. We will like dry run on example number 2. Example number 2 is 3 1 2, and our portions is 8 5 8. Okay, and success value is 16. You have to find greater than 16. Okay, so to find greater than 16, what we will do, we will start multiplying this 3 and we will count. Okay, so 3 multiplied by 8 24, which is greater than 16, so we will count as 1. Okay, just a minute. Okay, we will count this value as 1. Then 3 multiplied by 5, which is like 15 only, which is less than 16, so we will not count, increase the count. 3 comma 8, 3 into 8 is 24, which is greater than 16, so we will increment this count to 2. So answer is 2. Okay, for 1, let's calculate. So 8 5 8, so all of will be there less than 16, so count will be 0. For 2, 2 multiplied by 8 will be 16, 10 and 16, so two values will be greater than 16, so counter is 2. Okay. So we need to find the answer for each and every spell, for each and every portion. If I multiply and count, what will our term complexity will become like O of n cross n. Okay, and given that 10 comma 5 is the maximum n and maximum m, it will become 10 to the power 10, which will give us TLE. Great. So let's look at example number 1 again, and let's see how can we optimize it for a better use case. So this is given in array, and this is given another array 1 2. This example like in my mind. So both of the spells and portions are like not non-sorted arrays. There is not mentioned in the question that will be sorted, or that can be in any order. Okay, so I am making my own order like 3 comma 5 comma 1 comma 4 comma 2. Okay, this is our portions array example, for example. Okay, and now if I multiply 5 with 3, we will get 15, which is greater than 7, which is success value, and we will increase the counter. Okay, that's our case. So 5 cross 3 15, 5 cross 5 5 cross 4 5 cross 2. Okay, these 4 values will be like counted. 5 cross 1 will not be counted. Why? Because it's smaller. Okay. If I have 5 calculated 5 cross 3 and it's a greater than equal to success value over. Okay, do I need to calculate for 5? Do I need to calculate for 5? No. Do I need to calculate for 4? No. Since we know that if 5 cross 3 is bigger than success, then obviously 5 cross 5 is bigger than success and 5 cross 4 is bigger than success. So if I sort this array, doesn't matter because we have to calculate for each and every index anyways, each and every spell anyways. But here if I sort this array, it will become like 1, 2, 3, 4, 5, and we just have to traverse. That which is the point at which it will become greater than success, and then this is the length of array, that many counts we have. Okay, because sorted all the elements on the right of this point will be bigger than this, and all product of both of them will become greater than success. Great. So finding a pivot point in a sorted array will become like something like binary search, obviously. So we will having a binary search के लिए timeline. Portions is like smaller here. Let's take example 1, 3, 7, 10, 20, 500, something like this. Okay, and we will do binary search, like we will be calculating for midpoint. If it is all the values below this, let's take example, this is our answer. Okay, all the values below, let me change the color. All the values before this answer will be like negatives, because we will not find answer here. All the values greater than answer is positives. Like if I do product, it will be greater than equal to success. Okay, these are the greater than equal to success, this is less than equal to success. We will start from here, low to high. We will find a mid element. If mid element is success, then we are sure that this is pivot, or less than equal to this is pivot. We are here, we can reduce this high. Okay, and if we find this mid element will be something like here, then we will increase this low element to here, that we are not surely finding between mid and low, obviously, right? Okay, so it's a simple binary search algorithm. We will implement it for each and every spell. We have to check the same thing. Okay, so what will be the time complexity will become, like for the sorting, first of all we have to sort. So its length is m, so m log m will be the sorting complexity, plus we are doing calculation for each and every element of spell, which is length n, and for each iteration we are doing binary search on the portions, so it will be like m log m. So this will be our time complexity, and we are calculating it in an array, and we will be returning it. So apart from that, we are not storing it any of the values somewhere, like in a array, in a stack, in a queue, any data structure. So you can say space complexity will be O of n, and if I remove that complexity of the returning the answer, then it will be like O of 1. Okay, so let's clear the drawings and let's start coding this problem. So quickly code it, and equal to space dot size, and then int n equal to portions dot size. Great. Now we will sort this array, portions array. So portions dot begin to portions dot end. This is sorted now. Okay, so we will be treating over our spells array. I plus plus we will be treating. Okay, so let me create an answer pairs here. We'll create, what's the array then name? Pairs. Okay, pairs of length n. Let's put value as 0, because minimum pair count will be 0, right? Okay, so for each I we have to count pair, and we will set in that pair. Okay, what's the count? Okay, so let's check int count equal to 0, and at the end we will enter this count in pairs. So pairs of I will become count. How we are counting, which is the important thing. So we will doing binary search first of all, and we will see how we will count after that. Okay, so int equal to 0, high equal to m minus 1. So I have placed our low pointer at 0th index and high pointer at last index of this portions array, and we will be doing everything in while loop. While low less than equal to high, we will calculate the mid element first, which will be like low plus high minus low divided by 2. Okay, and then we check if spells of I, current spell, multiplication with portions of this mid element, which we find this mid is greater than equal to success or not. Okay, we will do this success or not, else we do something. Okay, so if it is greater than equal to success, what we are doing, we are reducing the high element, high of the pointer, so high equal to mid minus 1, and if it is less than equal to success, then we will increase the low pointer to mid plus 1. As simple as that. Okay, great. Now how I will count? So where our low and high pointer will be there after this complete while loop, based on this I can count. Okay, so let me explain you through this. So let's say this is our portions array, and we have multiple indexes here like 0, 1, 2. These are indexes, okay, not the values. 4, 5, 6, 7. Okay, so let's say our low pointer is here after this complete array. So this is our pivot point. Okay, so all the elements of this are our count. Okay, so how many elements are there? 4. So what is the array length? 8, and minus this is the pivot point 4. That's why height I can find something like m size minus this low point. This is our count. M minus low. Okay, these low elements are I am removing. These are not useful for me. Okay, m minus low elements are useful for me. This is our count. All the elements after this low will be greater than this pivot point, and if I multiply with the spells, it will come out to be greater than equal to success. Okay, so our count will become let me remove this drawing. Our count will become mid m minus low element. Great. So do we need this count? We can remove very well. We are not doing something rocket science here, so we can remove this count to be clean, and we will return this pairs array at the end. Okay, I hope it will run. Yeah, it's passed. So let's do one thing here. If I do something, okay, there is one more thing here left, because it's a long, so we have to typecast our product also in long form, so it will not be overflowed. Integer overflow error will not be there. Okay, let me submit this. Yeah, it's accepted. I hope you find this challenge interesting, and explanation is explanatory. Okay, so let's meet tomorrow. Happy coding. Bye.